Hey there, welcome to the special edition of ThursdAI. This special episode is featuring an interview with Nous Research, a group of folks who fine-tune open-source large language models to make them better. You will hear from Karan, Technium, LBJ from Nous, and Enrico, who worked alongside them. To clarify, Enrico is going in depth into the method called rope scaling, which is a clever hack that extends the context length of a LLaMa model significantly, and his project LLongMa, which is an extended version of LLaMa with 8,000 token context window. The first voice you will hear is Alex Volkov, the host of Thursday. Alex has asked me to clarify that he doesn't actually have a lisp. He was rugged by his microphone. With that, enjoy this special episode and follow Nous Research. They are doing great things.
Yeah, that's awesome. So I guess with this, maybe Karan, if you are able to, can you talk about Nous Research and how it started and what what are you guys doing, and then we'll dive into the actual kind of Hermes and Puffin and the methods and all of it.
Absolutely. Nous Research. I mean, I myself and many other of us are just like enthusiasts that were fine-tuning models since GPTJ or GPT-2, and we all are on Twitter, we're all on Discord, and kind of just found each other and had this same mentality of we want to make these models. We want to kind of take the power back from people like OpenAI and Anthropic. We want stuff to be able to run easy for everyone, and a lot of like minds started to show up. I think that Technium's addition initially to Nous Research, him kind of showing up, and himself, I, and Human working on compiling the Hermes dataset was really what came to attract people when Hermes came out. I think we just have a really strong and robust data curation thesis in terms of that. And I think that we have just some of the most talented people who have come to join us and just volunteer and work with us on stuff. And I absolutely must say, I can see in the listeners is our compute provider, Redmond AI. And, none of these models would be possible without Redmond's generous sponsorship for us to be able to deliver these things lightning fast, without making us jump through a bunch of hoops. Just a total pleasure to work with. So I have to show and say, I highly recommend everyone check out Redmond as well, because they really make our project possible.
Absolutely. So shout out to Redmond AI, and folks, give them a follow. They're the only square avatar in the audience. Go check them out. And Karan, thanks for that. I want to just do a mic check for Technium. Technium, can you speak now? Can I hear you?
Yeah, my phone died right when you were introducing me earlier.
Yeah,
What's up, everyone?
What happens sometimes on Twitter Spaces. Welcome, Technium. So briefly, going back to the previous question, I don't know if you heard it. What, besides the commercial and kind of the context window, what kind of caught your eye in the LLaMa, at least the base release, until you guys started? Or have you also, like the other guys, not had a second to play with the base model and dove into fine-tuning directly?
Yeah, the only thing that really caught my eye was the chat model and how horribly RLHF it was.
Yeah, I've seen some conversations about this and kind of the point of RLHF as well. And okay, so now that we've introduced Nous Research, I want to talk to you guys about what you guys are cooking, right? So we've seen the Hermes model before. This was allowed it as one of the the best fine tunes that I've seen, at least, and the most performing ones. Could you guys talk about the process to get to the Hermes model, the previous one, and then give us hints about what's coming soon?
Technium, you got this one, man.
Yeah, it was basically, I saw Alpaca and I wanted to make it, remake it with GPT-4, and then from there I just pretty much exclusively included anything that was GPT-4 only, and that was the beginning of the thesis for that. Going forward, though, we still have a lot of low quality data, I think, in Hermes dataset that can be cleaned out, and then there's a lot of new data sets that have come out that I want to start merging into there. I also want to move to something like ChatML or even Vicuna format so that we can do some multi-turn stuff. It's not very great at long chats.
Yeah, within the Hermes data set, a lot of it is publicly available stuff that's particularly GPT-4. Of course, Technium's massive GPT teacher data set. We also have a bunch of GPT-4 data we had generated that we didn't release necessarily just yet, as well as an instruction set that's particularly focused on tasks like Python, transformers, linguistics, very small data set of that's inside Hermes that, we don't really talk about much, but figure that would put some exposure to right now on the spaces. And yeah.
That's awesome. And so the previous Hermes was released on top of Llama 1, and for many folks, obviously they couldn't use this for different commercial points. And now that this model released, what the models that you guys released, how are you thinking about the license of them? And could you talk about like the availability of folks using them in commercial settings now that, the back of it is commercially available?
I think we have Puffin licensed as MIT. I'll have to double check on our own model. I think that's right, Karan, right? Or Tech?
Yeah, I think so. Either that or Apache 2.0. Like, if the base model is commercially usable, the stuff we put out you're good to go.
Yeah. Yeah, and like in our announcements, I put in kind of, one of the main things. It's commercially available, like the first Nous. As far as I think, I'm pretty sure it's the first commercially available Nous model that's released. And a big differentiator from Hermes is the fact that, like Tech was saying, Hermes is pretty much all single turn data. And it surprisingly can do actually like pretty decent at multi-turn conversations when you actually use it. But then Puffin is almost kind of like a 180 where it's a vast majority of really long context multi-turn data. And I think can you guys hear me still?
I can hear you.
Okay, it's just something's up with the app. Okay. So Puffin is a vast majority multi-turn data, GPT-4 specifically, and a lot of it is actually real human conversations with GPT-4 that go on for some of them 4K context, 6K context, like even all the way up to the max 8K context length of GPT-4. And then we took those few thousand conversations of real humans interacting with GPT-4, and now after that, I'm not sure if a lot of people probably heard of Camel AI. So they have the physics, biology, chemistry, and mathematics data set. And then within those, there's a bunch of subtopics that you can curate through. And I just pretty much spent a good few days curating, just handpicking the right subtopics like differential geometry, logic problems, optimization problems, a bunch of different GPT-4 examples and responses from those different subtopics. And then I specifically added those in certain ways to the Puffin dataset.
That's awesome. So just briefly for the audience, maybe the Puffin model that I think the official name is the Redmond Puffin 7B or 13B.
Yes.
This is the model that you guys fine-tuned, and one of the first, it may be not the first fine-tune of LLaMa v2 that's now publicly available, like you said, maybe with MIT license on Hugging Face, and I think you even added the GGML quantized version, correct? And so folks can go and download that and already start playing with this. And so first of all, thank you for contribution to the open source. That's great to see. And the speed with which you guys fine-tune this is also great to see. And maybe now that we've introduced this, maybe this is like repeating a bit. So could you speak about the difference? So the difference is in the data set, in the tasks that you fine-tune? Like what is the actual difference between the Hermes or the Hermes that's coming out and the Puffin models? What would people use them for differently? If that makes sense as a question.
The Puffin model will definitely be better at multi-turn stuff. That's for sure.
Yeah.
So if you want to do a team like OpenAI,
I'll paste the link above for the GGML version of it, because I'm gonna test it thoroughly, but I really think because you guys have used GPT-4 high quality multi-turn conversations, then this can have actual like practical use for whoever else wants to use it, either as like something that tells you about the documentation on the site or walks a user through. In other words, this should be better than Hermes then, in for like customer service stuff, which is just one example. Anyway, yeah, I'm gonna try. I'll paste the link above.
Mm-hmm.
It's likely better for production use alongside like stuff that you have with like a retrieval pipeline, like with LangChain, etc. Like I would believe that without testing it, or just talking, of course. But there is, even though with this LLaMa technique of small examples, we can get like a really good model that does really well. The thing about Hermes data set and just its size and the various types of data and topics that are in there, I think you get a totally different like role play or storytelling experience or completion experience with Hermes. Personally, I feel that way.
Awesome. So, and
another thing about Puffin data set is that it does go up to like 8K, and Enrico here has been doing a ton of work on extending LLaMa's context.
Right. So I wanna give an introduction and then introduce Enrico and talk about this real quick. Right. LLaMa version 1 was released with, again, 2,000 tokens in the context window, and then many folks, including Kayo, Ken Dev, and Mozilla, right, and some other folks, I think, were involved in bringing some of the quote unquote tricks about what eventually ended up being named rope scaling, if I'm not mistaken. And we've followed this, and we've talked about it previously in ThursdAI. And LLaMa v2 was released with 4,000 tokens in the context window. And, we're now so used to kind of Claude and the 16K GPT-3 that 4 didn't seem like a lot. And then many folks were wondering, and meanwhile Enrico was working, whether or not the rope scaling method would apply to the next LLaMa, and it looks like it did. And so I want to introduce Enrico Shippole. I hope I'm saying this right. Welcome to the stage. Hopefully you can unmute and the space works with you. And the second fine-tune that I saw was also back with Nous Research, and this was the extended version, what's called LLongMa. So Enrico, welcome to the stage, and feel free to introduce yourself, your affiliation with Nous and LLongMa with the context window.
Hello. So I'm actually an independent researcher. I'm sponsored by Stability AI, Luther AI, and a few other different organizations, including Nous Now.
Awesome.
I work with different people like Tanishram Medark, Aaron Komatsuzaki, who also is from Luther and Duck AI, John Ney from Nomos AI. So I have a lot of affiliation with a bunch of different organizations, including Together. We're starting a project right now with them.
That's so great to hear. And so welcome to ThursdAI, welcome to the stage. And can you talk to us a little bit about kind of the rope scaling method and how were you able to like find them like this quickly, and how the results look so far? I wasn't able to run this myself, but hopefully, talk to us about LLongMa.
Okay, so initially, the thing is, I actually was hoping that both Mozilla, Bowen, and Kayo Ken Dev would have been able to make it, because it was kind of like a equal parts effort on like all fronts from each of us. Initially, I had trained some pathways models at 8,000 context length about 4 months ago, based on the exposition paper, which did rotary embedding scaling initially. They were one of the first people who did it. They based their methodology off of Ophir Press's Alibi. I would imagine that most people are pretty familiar with Ophir Press and his work on the alibi positional bias that's been used in a wide range of models now. So Mozilla and I came into contact based off of the work that he had seen me doing with the POM models, scaling those to 8,000 context length pre-training, not fine-tuning. So what we had initially done is basically take a section of C4 in different data sets that had examples that were all over 8,000 context length and pre-trained on them, packed together with a beginning of string and end of string token to help with like the attention masking portion of that. After he had seen that, Mozilla actually became into contact with Kyokendev, I believe Kyokendev is how you pronounce it. Kyokendev had also been following Ofer Press's research. He had started working on his own version of scaling the rotary embeddings, I believe based off of both alibi and exposition. And what he found is that by scaling the max positional embeddings in the rotary embedding from something like 2048, which you would initially train with, he scaled it up to 8000 or 8192. And he found that by applying like an interpolation to the encoding, by scaling basically like the positional index in the rotary embedding, that you were able to essentially turn down the frequency window in rope by like a factor of 0.25. The scaling depends on the length that you're trying to extrapolate to and the initial context length that the model was trained with. So if you were training with LLaMa 2, which had an initial context window of 4096, and you wanted to do the linear interpolation positional scaling to something like 8192, then you would use a scaling factor of 0.5. If you were trying to do it from 2048, which is what the original LLaMa was trained with, and you wanted to scale it to 8192, then you would use a scaling factor of 0.25. So basically, after we had done all of this, Meta had released a paper around the same time that Kyokendev had released his blog. They both found very similar findings. They had shown in the meta paper that you only had to fine-tune for 1,000 steps with the linear positional interpolation scaling to be able to get the benefit of doing a full pre-train at a context window of 8,192. So this is actually like a big step because it shows that you no longer need to pre-train right off the bat at a longer context length, that you're able to do the fine-tuning on essentially a lower resource like computational budget and still be able to get the like greater results of the longer context window. I know a lot of the major AI companies had been doing, just for my work and personal research with many of them, had been doing staged scaling of the context window during training. So they would pre-train, basically when pre-training, they would separate the initial examples from a data set into multiple stages. So anything that is under the window of 2048, you'd separate from the initial data set. Then you take things between 2048 and 4096, and then 4096 and 8192, and you would basically chunk the data sets into those different parts. You'd first initially train on the 2048 chunk of the data, then you would train on the data between 2048 and 4096, and then you would do the same thing from 4096 to 8192, or if you want to scale that to 16K or 32K context length. But what we have shown now with both the meta paper and this, that you don't even need to go through that extensive pre-training and staged process. You can just go from a context length of 2048 to 8192, scale the rotary embeddings by whatever type of factor that you want to use. So like I was saying, if you're going from 2048 to 8192, you'd be using a scaling factor of 0.25. It only needs 2 lines of code to be able to do that. In the LLongMa post, I had provided an example of scaling the rotary embeddings. The code was written by Mozilla or Jeff. We also came into contact with, after all these experiments were done, came into contact with Bowen, who had worked a lot on the dynamic NTK scaling with Mozilla, and he had also done NTK by parts, which we're currently training a lot of models on. So we have the LLongMa 1 models trained on the OpenAI series, like the suite of those models that use the linear interpolation scaling. We now have the LLaMa 2 models, or the LLongMa 2 suite, which is what we're calling it. Again, trained on the linear interpolation scaling. And then we have another suite of models coming out very soon that uses the NTK by parts dynamic scaling, that was really specialized by Bowen, so I do not want to speak on his behalf. It'd probably be good to get him to talk about it in another one of these.
Absolutely. So let's get in touch after this and set it up. So thank you for the very in-depth kind of explanation, because we did cover the kind of the rope killing and how Kaioken in the image boards or Reddit or wherever he started this in his blog post, and then how it's going to rotate it. It's great to actually hear from the folks who are doing this. I just, for the audience, I've attached Enrico's tweet about LLongMa 2, which is now currently trained at 8K context length. And Enrico, you told us that we may see even double from this. So could you speak about the next version?
Okay, so the initial training process of doing this up to a context like length of 8,192 can be done basically with deep speed 0.2 and activation checkpointing, and you're able to fit the model on a 100 80 gigabyte node. Now we are working on the process of scaling it both to 16K and 32K. This requires a different methodology during training. You either need to use deep speed 0.3 or fully sharded data parallelism. Both of those are very similar for people who aren't aware. Basically, you're just sharding the optimizer states, the model states across like different nodes. You can also use things like tensor parallelism to help with the scaling as well. And then we're going to be basically just adjusting the scaling factor again, collecting a large, we've already collected a large quantity of data at 16K context length, and we're going to be doing the fine tuning to 16K and be releasing those models soon. All of this computing is sponsored by Stability AI. They've been very generous with helping with a lot of the independent research.
So I want to shout out Stability AI for not only giving the world stability diffusion, but also participating in this kind of next wave of AI. Many folks kind of coined the Stability AI moment when they released Stable Diffusion. I want to say 1.4 back then, almost a year ago now. And many folks are saying the same about the LLaMa 2 release. Now that it's commercially open source, and folks can start like doing things for profit. Companies can join. So we definitely want to shout out Stability for the effort here. Enrico, thank you. And folks, please follow Enrico and we'll stay tuned. I want to ask Karan and Technium and other folks from News, the efforts that Enrico is talking about, the longer context windows. How would they kind of interplay with the stuff that you're working on with Hermes, with Puffin? Are kind of the efforts interchangeable? Are we going to see building on top of each other?
So I think LDJ can definitely speak to this, but I'd like to happily say that once we did LLongMa 1 on the first LLaMa generation of models, we already had Puffin 2K, 4K, and 8K for that already prepared and ready. So as the LLongMa models for 13B are released, we will also be doing equivalent Puffin fine-tunes and potentially Hermes fine-tunes. We can talk a little bit more about the future of Hermes at a little bit later, though.
Yeah, I mean, I was pretty much going to say the same thing, but kind of elaborate on that about how before, when LLongMa V1 and everything, and during the development of LLongMa, there was actually of course, me, Enrico, who I usually just called Concepts of Mind, and Emozilla. We've all kind of been butting shoulders a lot together, and just kind of working closely, on the same Discord and whatnot. And it's hey, working on this experimental LLongMa thing, hey, you want to try fine tuning? And then the plan just kind of ended up being okay, just gonna have this Puffin thing. That Puffin dataset is already containing a ton of high context conversational data from GPT-4 and human high quality data. So it's the perfect fit to have something that's high context capable be fine tuned on that. And then LLaMa 2 came out, and it's oh yeah, let's get this out ASAP, and then we'll figure out what we're gonna do later. Yeah,
Great. And it's just great to see how many opportunities like this with open source and the stuff that we're able to now run and gonna iterate on are building on top of each other. They're just incredible, and this is maybe a watershed moment. And I want to thank all of you for being here. I want to kind of let the other folks who usually here on ThursdAI maybe ask you a question or two for news research. Yam and Nistan, if you have a question for news or for Enrico, go ahead. I will say, Yam, I know you. If you ask about the super technical stuff, and the audience will it will fly over their heads. I will introduce you in the DM with LDJ and Enrico. But yeah, for the stuff that we haven't covered and interesting stuff on news, feel free as it pertains to Llama 2 is going to be very interesting, I think, for everyone.
Just to quickly clarify, you guys fine-tuned the plain model, right? Not the chat one.
Yep.
Okay.
Yep, the base model. We wouldn't fine-tune that model, the chat one at all.
Actually, to maybe continue this, sorry, Karan, for interrupting, just 1 sec. To continue this question, there were models that were released by Meta, and you had to register and get the email and everything, and then they put some stuff on Hugging Face, and then those models were delineated with -HF. Have you guys used the Hugging Face one or the Meta one, and do you guys know the difference? I saw somebody that maybe it doesn't work as well in Transformers.
Yeah, the one on Hugging Face is in FP16, and the original LLaMa 2 model is in BF16. But we tested the difference between the two models at Carper, and there's such a negligible difference in their quality that it's irrelevant. But we trained on the Hugging Face FP16 ones, but in BF16.
Awesome. Sorry, Karan, for interrupting. Go ahead.
No, all good. I totally forgot what
yes, I interrupted your train of thought. Okay, Nistan, if you have a question for Karan to follow up, feel free. And if not, then Yam, if you have anything that you want to ask the fine folks from news, feel free as well.
Yeah, sure. First, thank you for what you're doing, guys. You're really making a difference. For anyone, there aren't many demos online, so anyone that didn't try Hermes, I highly encourage you to try. I don't know why there aren't okay, I know why there aren't demos. It costs money, but just try it, okay? And now I got a question, because from my experience, if you train on the open datasets of Hermes, you get a significantly less quality of a model. Now I'm fine if you don't release datasets, don't get me wrong. Just, I wanted to ask, is there anything else besides the data that is different? What tips can you give for, I don't know, someone else that want to train high quality model besides having high quality data? Everyone understands this.
Yeah, the hyperparameters can make a huge difference. LDJ knows very well, because we had to do a ton of different tests on hyperparameters for Puffin model. But I'm not sure if those are on the model card for Hermes. If they're not, I can put them on. And Karan can probably talk about the news data sets that weren't made public.
Yeah, we've got maybe around 50K items of data, versus total 300K instructions in there that are not released. And to be frank with you, about 45K of them is just more GPT-4 alpaca style instructions. The 5,000 or so, 4,500 of them compose this data set we've been working on that, at this point I'm pretty comfortable talking about. We call it the P-dactyl data set. I won't speak on everything that's in it, but essentially, and I don't know if this is the thing that made the big difference, but it's the one place where I guess you deviate from just using the open data sets and more GPT-4 instructions. But it's got some transformers instructions, some linguistics instructions, some calculus 1 instructions, etc. It seems to be pretty good.
Also, Yam, do you have links or anything to the models that tried it with just the makeup of the data sets that were public from Hermes? Because I haven't actually seen that before.
Again, can you repeat that? I didn't hear.
do you have any links to the models that trained with just the open data sets from Hermes that you could share with me later?
No, it's just from my experiments on training, pretty much following the same idea of let's take only GPT-4 from all the open data sets. The model that you get is different, for sure. And it might be the hyperparameters,
Another thing that we did too is pretty extensive like cleaning. We did deduplication. We removed things like URL, like any response that had a URL in it, we removed in case it was going to give like hallucinated URLs. We did a set of like maybe 8 different filtering processes too that might have made our data quality higher.
So,
as an AI language model,
for anybody in the audience, that hyperparameters are just like the settings in the oven. So it looks here like the ingredients were all okay, but you messed something up before setting it to cook, and it just came out half-baked, the model. So we're going to have to check that out.
Yeah, I'm a big proponent personally of hyperparameter optimization being underrated right now, like in the current space. And that's something I've kind of focused on a lot, specifically for things like Puffin, and just trying to help others around in use and stuff, like trying to optimize what they're doing. And even just something like what you just said about the settings for the oven. I mean, double the amount of time you're putting something in the oven, and it's not going to come out twice as good. It's not even going to come out 10% as good. It's going to come worse, And all depends, like, what is your baseline for how much time you're putting it in the oven, and all these different variables that kind of are dependent on each other and affect each other. So it's definitely something you kind of have to build an intuition about to some degree. And then the other end is really, I feel like there has to be more investment and more time and energy invested into actual tools that make hyperparameter optimization easier for people that are doing these things.
Yeah. The thing is that the models are really big, so it's really expensive to run them. So you have a trade-off of how much compute are you investing in searching hyperparameters rather than actually using it for training. But I completely agree. So one last question, actually, too.
Actually, one thing before we go on, something great about the Puffin data set is that it's just like 3,000 or so examples, I believe. And so it makes tuning a lot less expensive because you can finish the whole training in just a couple of hours. So like with Hermes, if we wanted to try full ablations in dozens of them, it would take weeks and weeks to do.
Yeah. Well, to be fair, it's not like it only takes a couple hours on one GPU. We use 8 A100s, 80 gigabytes. So, yeah. Courtesy of Redmond.
Thank you, Redmond.
I should also probably clarify that when doing the context length extrapolation, we're doing it on 1 billion tokens and 64 80 gigabyte A100s. So.
I was getting overexcited. All right, folks. I want to maybe ask Karan just one last thing, and we'll move on to the regular ThursdAI update kind of cadence. Sure. But I will say that, like, folks from Nous Research and Enrico and some other folks here, thank you so much for coming up and giving us kind of the insights into how this actually happens. LLaMa 2 just released it, a few days ago, and you guys are already pumping out like open source fine-tuned models, and it's great to see. And just so you know, there's always a stage for you here to come in and announce things. And if you do want to announce like a release or something, maybe just right now, Karan and Technium and some folks, I would love to hear about like when the next Hermes is coming.
Before we say that, I just would like to clarify something about Hermes. So we have the original Hermes dataset on LLaMa 2 as something that we will release, but also a sequel to the Hermes dataset, Hermes 2. There will be a distinction between these two, and you'll see the prior come out first and the latter come out after. But as for release, etc., I will absolutely let Technium take the stage with those final words.
So the training is nearly done. At least it was about 2.8 epochs out of 3 a few hours ago, so it might be done already. Before I release it, though, unlike Puffin, we wanted to get Puffin out like same day that LLaMa 2 came out, so we didn't run any benchmarks, and we had to put all the compute we had on Hermes immediately after we were done with that. So we don't have any compute to do any benchmarks or Puffin until Hermes is done. But before I release Hermes, I do want to do like a full range of benchmarks and stuff like that to make sure everything's good and have a pretty detailed model card. But that should probably only take the rest of tonight at the most. So probably tomorrow morning would be when Hermes comes out.
That's awesome, folks. And you heard it here first, and definitely follow Technium, Karan, Enrico, LDJ, and the rest of like News Research folks. And stay tuned. Enrico, go ahead.
Yes, I just wanted to piggyback off of Technium's comment a little bit. So we did do pretty extensive evaluation of the LLaMa 2 8K models. We had run different things on Perplexity, using GovReport and a couple different other data sets to make sure that the length extrapolation and the context was working properly. We did passkey retrieval. We also did a lot of extensive human evaluation, which took a little bit. I had wanted to get the LLaMa 2 8K models out yesterday, but we decided to push it back one day. And what we were doing is we were feeding it research papers and seeing if it could pull out even like relevant pieces of information from the context length. And so far, it has been quite successful. So we're still running more evals, but the ones so far have shown that there's been like no performance degradation, no matter what context length that you're basically using with these extended models.
That sounds great, and now that this LLongMa is out and the next versions are going to come out as well, I'm sure that some other folks will also contribute to this research and tell you like from their own experiences and vibes. So yeah, I want to thank folks again. This has been very illuminating and very glad to have you. And obviously the stage is yours whenever you want to come here, and we appreciate you. And you guys are welcome to stay tuned and kind of chime into the rest of the updates. And with that, I think for folks in the audience, we're moving to the next